Hey there, you 12s. In this example here, we're going to be calculating the cut capacity. So in flow problems, we need to now think about, well, what edges are going to be included and which edges cannot be included. And they use what we call cuts, which is in the dotted lines there. And where you cut essentially separates what they call the sink again to the source to the sink. And we know that the source is where the water's coming from, if that's what we're using it for, and then T is the sink. So if the source of water is coming here, then there are two options in cut number one. You see, so if I used a cut and I cut these two edges, which means that the flow that goes to S to B and the flow that goes from S to F, we've got 15 and 20 there. So even though I cut it, technically the pressure or the amount of water that's coming out is 15 towards B and then 20 towards F. Okay, so we would then say, well, in cut 1, so C1, that should have a total flow, okay, a total of a capacity. Okay, so the capacity, right here, capacity would be 15 plus 20, which is 35. Okay, and then if you calculate C2 on the other hand, so what's interesting here, C2 cuts through three edges. It's cutting through here. So remember, this is now flowing at 15, but remember this can only, B to C only takes 14. So in our maximum flow problem, we know that because it can only take 14, well, technically at this point, as it's flowing out, it can only flow 14 when it gets cut. Whereas on the bottom, though this is going 20, right? It gets to F and it's definitely 20, but then F cannot go to B because the cut had already happened before I even got to F. So that means the flow that I get is only 20 from the bottom. And then on the top, it goes 15, but then it can only have a maximum 14. So therefore, plus 14, and that gives me a total of 34 if I had cut number 2. And if you then had a look, well, what if I cut number 3, right? So again, 3, there's 3 cuts there. So if that is the case, again, 20 from SF comes down. So again, I can still go 20 and it gets cut. So at this point, I still have 20 on this edge. And on this side here, that's a 15. There's a flow of 15 there. So I would have flow of 15 coming out this way. And then if you think about it from here, S to B was 15, but again, it gets funneled at 14 by the time it gets cut again. So I've got 14 there. So you can see that the capacity, okay, the cut capacity in this area, in C3, is now 14 plus 15 plus the 20, which is what's that? 35 plus 10, 45, 49. I think. Yeah, that seems about right. And then cut 4, on the other hand, if you have a look at cut 4, so again, let's have a look at the flow in cut 4. So cut 4 cuts out 3 edges again. Quite similarly, we know there's a maximum of 20 here, so 20 is coming through, and so really we've got 20 at C4. We can see that therefore 20 doesn't get to D, and so therefore this third edge or second edge does not get included, so 12 is not included. But then we can see that F can go 15 all the way to C, and then up here, remember this was S to B is 15, but then it gets funneled at here from B to C is 14. But regardless of what happens here, 15's coming in and 14's coming in, but remember the maximum capacity is only 10. So therefore, by the time it gets cut out at this point, I can only have 10 as my actual value that's coming out. Does that make sense? So therefore, cut 4 can only have a maximum flow of 20 or capacity of 20 plus the 10, and that gives me 30.